Hello everyone. Today we will see one of the very important topic from the data structure, that is trees. So what is meant by tree? So tree is a non-linear data structure which is collection of different objects and entities, and these objects or entities are called as nodes, which are linked together to represent or to simulate a hierarchy. So why it is called as a non-linear data structure? So basically whatever data we are storing in trees, they are not storing in the sequential manner, therefore it is known as non-linear data structure. So it is a hierarchical structure, as elements in a tree are arranged in a multiple levels. In a tree data structure, the topmost node is known as the root node, and every node contains some data, and that data can be of any type. Each arrow shown in the above figure is known as link between two nodes. So this is the diagram for our tree. So we'll see the different basic terminologies from the tree data structure. So the topmost element from this tree is known as the root element or root node of the tree. Then there are different nodes are given here. Some are like the parent nodes, or they are the others are the child node, then sibling node, subtree, what is meant by leaf node, and what is meant by labels in a tree. So we'll see one by one. So what is meant by root? So the root node is the topmost node in the tree hierarchy. In other words, we can say the root node is the one that does not have any parent. Now what is meant by parent node? If the node contains any subnode, then that particular node is known as the parent of that subnode. Then next is the child node. What is meant by child node? If the node is the descendant of any node, then that node is called as a child node. The next term is a sibling node. So what is meant by sibling? The nodes that have the same parent, or the nodes from the same parent, we can say they are the siblings or brothers and sisters of each other. The next term is a leaf node. So what is a leaf node? The node of the tree which does not have any child node is called as a leaf node, or it is also known as terminal node, or it is also known as external node. So there can be any number of leaf nodes are present in any general tree, and the leaf node is the bottommost node of the tree. The next term is the internal nodes. A node that has at least one child node is known as an internal or a non-terminal node. The next one is the ancestor node. Ancestor node is any predecessor node on path from the root to that node. The root does not have any ancestors. No, root node is the itself parent of all the nodes. Descendant node. Descendant is nothing but it is we can say the immediate successor of the given node is called as descendant of a node. The next term is levels. So levels are nothing but they are representing the generations of the node. Suppose if the root node is at level 0, then its next child node is at level 1, then its grandchild is at level 2, and so on. The next term is age. So what is meant by age? In a tree data structure, we can say the connecting link between any two nodes is called as an age. In a tree with n number of nodes, there are a maximum of n minus number of edges. Then what is meant by path? So path refers to the sequence of the nodes which are connecting to the edges of a tree. Next term is a depth. Depth of a node or depth of the tree. So in a tree data structure, the total number of edges from the root node to a particular node is called as a depth of that node. And in a tree, the total number of edges from the root node to a leaf node in the longest path is said to be the depth of the tree. In other words, simply we can say the highest depth of any leaf node in a tree is said to be depth of that tree. In a tree, depth of the root node is 0. Then what is meant by subtree? So subtree, each child from a node forms a subtree. Every child node will form a subtree of their parent node. The next term is degree of a node or degree of the tree. So the total number of children of a node is called as degree of that particular node, and simply we can say the degree of a node is the total number of children it has. The highest degree of a node among all the nodes in a tree is called as the degree of the tree. The next term is height of the node or height of the tree. The total number of edges from the leaf node to a particular node in the longest path is called as height of that node. So in a tree, height of the root node is said to be height of the tree. In a tree, the height of all the leaf nodes is 0. Then next we can see the applications of trees. So whatever data we are storing in our system, so it is use the tree data structure. By using this tree data structure, we have to store the data in our system in a hierarchical structure. So therefore it is said as storing naturally hierarchical data where it is used. For example, the file system, whatever we have stored on our disk drive, it is using the tree data structure. The next application of the trees is it organizes the data. It is used to organize the data for efficient insertion, deletion and searching operation. Then it is a special kind of tree. Trie is a special kind of tree. It is used to store the dictionary. It is a fast and efficient way for dynamic spell checking. The next application of the trees, it is used in the heap tree data structure, which is implemented by using the arrays, and it is used to implement the priority queues. The B and B plus trees are used to implement indexing in the databases. Then the application of a tree is it is used in the routing table, where it is going to store the information related to routers.